All aboard the live stream train. Toot toot. Good morning, everybody. So is it train or drain? I don't know. I lean more towards drain. I acknowledge the traditional owners of this land, the Whadjuk Noongar peoples. I pay my respects to their elders, past and present, and to Aboriginal elders and peoples from other communities who may be taking part in this live stream today. Welcome. Welcome, everyone. Good morning, Amanda, Henrik, Rob. Scrolling down, Tradie Chip is here, and Peter, David Howes, David Crisp, Russell, Keith H. Good morning, Keith is here and ready. Imi is here, Jax Tech, Gerald, Stephen, Illuminator, James. Yes, you made it. What is going on with... So it's daylight savings, just started, so I'm 1 hour earlier on a relative to GMT, I suppose you'd say. Mike, good morning, Mike. Yes, 1 hour earlier than previously, and yet we still have a decent number of people here right at the start, so everybody must be ready for it. UTC, says David, relative to UTC. Okay. What's Zulu time? Isn't Zulu I don't know. American military uses stuff relative to Zulu time. I don't even know what that is. Is that the same as GMT? Could be. It could be a way of saying GMT without admitting to Greenwich, because we don't want to reference those English. Can't give them any credit. Jackstack says Zulu is 24-hour UTC. Okay, cool. And David says Zulu is the same as UTC. Yeah, right. Yeah, okay. Amanda said I've updated the present center document and I will add to it over the stream. Great. So that is something that we will definitely look at today. I'm not going to start with that immediately though, but sorry, I've just got to mute my phone because I'm getting notifications and it will break my brain to see notifications buzzing up in the corner of my field of view and buzzing. So, yes, we will get to the present sensor project in a little bit. I just wanted to do a couple of other briefish things first. Briefish things. First thing is just a funny story from last night. So I was at a party last night and one of the other... So this story is a funny way of getting an autograph, basically. So one of the other guests at the party arrived and she was a bit late because she had been in at the MCG doing hospitality work in one of the VIP areas and serving drinks to famous people, that sort of thing. And there was an old guy there, so she was talking to him and said, "So what's your name?" And he said, "Oh, it's Gene Simmons." And she said, "Oh, can you please write that down so I don't forget it?" So he wrote down his name on a piece of paper for her. So she came to the party with Gene Simmons' autograph. I just thought it was a funny way to ask for it. Can you please write that down so I don't forget it? Oh, Gavin is here, Argon, Johan, Celtic Beast. Did I say hello to Celtic Beast earlier? May have. I can't remember. Okay, so the other thing is this. Where are we? This. It feels like I'm never going to get to the end of this. This board has been sitting, out of sync. Okay, let's push to 3D. Do that. Push to 3D. Go. This board has been ready to order since, was it the last live stream? Or the live stream before? It's been at least a week, maybe a couple of weeks. It's one of those things where if I don't take the final step and just order the damn thing, it's never going to happen. And of course, I could do that at any time during the week. There is nothing to stop me doing it. But doing this stream, it's kind of like an accountability thing. I need to just do it. I need to just order it. Oh, is that correct? Did I? Yes, I did put the... Oh, I know what's missing. There is something very important that is not on this board. There is no Steve. I have got to Stevify this board and then I can send it off for production. Okay, so where can I get a Steve from? I will grab a Steve from some other board. What board? Maybe Rack 32? Hang on, what was that? What road? Oh, road go. On the left here, I don't know whether you can see this. There is this project and it just looks like gobbledygook in the name. And when I first saw this, I thought, what is that? Like, did I just mash the keyboard? Because it's hard to parse words out of this string of text. But no, what that actually is, what that means is Road Go Dock. It's a charging dock project for the Road Go microphones. Why did that confuse me so much? Rack 32. All right. I am pretty sure that there is artwork for Steve in the Rack 32 project. So I'm going to grab myself some Steve from there and add the Steve to... No, Peter. It was a G, not a C. Yeah. It was... oh, Sion's here. Missed the start. Oh, we've been going for an hour. Didn't you know? You know, the clocks move forward 2 hours on October the 1st. Good morning, Sion. What am I doing? Okay, so I am looking for some Steve. T-Place. There is some Steve. Let's grab ourselves that. And is this going to work? I'm not even sure. It can only be inserted into a synchronous project. Please link. What? I don't even know what that said. What I'm trying to do is copy. Hang on. It says a 2D PCB project or design can't be inserted into a synchronous project. Please link a corresponding schematic to your electronics design file. What is that complaining about? What? Why is this... Rack 32, yeah. Is this Fusion just being broken again? Oh, which reminds me, I wanted to show you a little animation of a cool new feature in Kicad. I think it might be an add-on. I don't think it's in the current Kicad release. Why can't I select... Alright, let's just drop out of single layer mode and copy group. I'm just going to try copying anything in here. Just copy part of that artwork. Copy group. Then it worked. Why didn't it work before when I was in single layer mode? Okay, I'm going to go back to single layer mode or focus mode or whatever the thing is called. Maybe it's because, it's because I had that part selected as well. Okay. Yeah. Fusion, you're pissing me off. So I'm just going to have to manually select these other segments. Come on. So that I can, yeah, so this little Steve I just made out of short segments of curved track. Do I have all of it? Yep. Okay. And copy tool, copy group. All right, now maybe I can stick it into the OpenKO board and do a Control V for paste. Maybe we should have Steve on his head. Get Steve upside down. I'm just going to drop Steve there for now. Go to the top layer, T-Place, focus mode again. Maybe Steve could go down here somewhere. Or up here. Where will Steve fit? Let's, I've got to reselect that group. yeah, so the thing that where will Steve fit? Not quite there. Yeah, he'd fit there. That's as good a place as any. But it would also fit down here. Let's just stick Steve here. What's that part? Oh, that's a fuse. That's okay. That'll do. Steve can go there. All right. Doesn't need to be anywhere in particular. And come on, drop out of single layer. Save, save, save. Anyway, the point of all of this is I'm just going to generate files and upload them to JLC. If I don't do it right now, then I probably won't get back to doing it during the week. All right. Yes, save. Saving takes so long when it's got to sync. Upload progress. Every day I become more and more frustrated with this, and I know people are going to keep yelling in the comments, why don't you just change to Kicad? Yeah, that's going to happen. It is. Like, I wasn't being sarcastic then, that is actually going to happen. Okay, I've got to do a network chuck just for a moment. Better. What was I doing? That's right, pushing to 3D. Go, go, go. Yeah, so the thing that I was going to show you, in fact, while that is pushing to 3D, I'm going to have a quick look on my Twitter, where is it? On my Twitter feed, because I reposted, oh, here we go. It was from Arturo. Arturo posted this. I'm going to bring it up. Video by Mike Williams. I wonder if I can like full screen this or something. Can I do this? All right. So this is pin help, like a pin helper function inside Kicad. Check this awesomeness out. So this is a symbol for an STM32. Doesn't matter what it is. The point is there are a bunch of pins here. And a really common thing to do is you want to break out from a chip and generate a whole bunch of nets or something from it. So check out this little piece of awesomeness. Select the pins, go to pin helpers, wire, bah, look at that. And no connect, you can mark them all as no connect. And pin helpers, global labels, so stick labels on that match the signals that are defined on the symbol. All this cool stuff. So this would be a real time saver when dealing with a bunch of pins that you want to break out from something. And I think that's just looped back to the start. But that little thing is really cool. Yeah, there are similar things in Fusion Electronics as well. But it is really cool to see this in Kicad. So Kicad is developing so fast. Where is this? Yeah, pin help added to key. Oh, okay, so it's in the nightly build, all right? So it's not like an add-on or anything. It is actually in the nightly build for Kicad. That is nice, very nice. Keith H said DRC check okay. I believe I did a DRC check previously. Let's just close this up. I don't want to save the Rack 32 changes. Rack 32 don't save. So this is one thing that, yeah. I'm trying to resist the urge to falling into the trap or the habit of just complaining about every single little thing about Fusion that annoys me, because me doing that just annoys everybody else. But what I was about to complain about was the fact that Fusion flags the project as dirty, as in requiring saving, no matter what you do, whether you've made changes or not. So for example, if I'm just going to save this. All right, so this is a saved version. This will be a saved version of the project, Once it finishes, it's synced, so now we'll end up with version 61. Once that finishes its upload, come on, come on, come on. So it takes, all I did was hit Command S. I'm just waiting for this project to save. And it's still going, so still uploading. We'll get there eventually. Hitting save on a project should take fractions of a second. It should be so fast that you can't even tell. This still hasn't finished. It's still saving. There we go. Upload is finished. All right, it took that long to save. All right, so we're at version 61 now, and you can see that there is no little asterisk next to it, which means that it has not been flagged as dirty. So the project is not needing to be saved. Now, if I do what will I do? I'm going to do something that doesn't actually change the design in any way at all. All I'm going to do is pour the polygons, which is, like, the polygons are all there. All this is doing is like a rendering change. It's just saying, all right, so I'm going to hit rat's nest, pour polygons. All right, I didn't actually change the design. All I did was fill in the polygons, and you can unfill them as well. But look, it's flagged the project as dirty, and now it thinks that the projects are out of sync. It says 2D and 3D documents are out of sync because all I did was change like a view mode. Okay, that's enough of my complaining about stupid Fusion things for now. Where are we? Back to 3D, but you're right, Keith. I will do a DRC again just to make sure. And now we have, I might as well get rid of that data panel for now. And now we have Steve. Yeah, you're right, there's no Steph. And this should now be ready to send off, but I will do a DRC. I'm pretty sure I did an ERC. I did all of this on stream previously anyway. All right, so we've got errors, drill size. Okay, so it's complaining. This is because of settings on the design rules for the via size, and what is this set to at the moment? These should all be 0.5 millimeter vias. And come on, info. All right, so that is, yes, it's a 0.5 millimeter via, which is fine. It's just that the way the design rules for this are set up complain. And because I had moved, I probably moved 1 or 2 vias or added a via, it then flagged every single via as being in violation, even if I had previously approved it. So can I? Nope, I can't bulk approve those. So screw that. I'm just going to ignore that. Wire stub. Okay, this could actually be something that I screwed up. Yes, there's a wire stub. All right, so I must have rerouted that at some point. Let's delete. Come on, why can't I delete you? Okay, so delete the wire stub. That wouldn't have actually caused a problem. It wasn't. It wouldn't have added any copper to the board or done anything like that. But we now have, yeah. So thanks for reminding me, Keith. I sometimes do forget to do DRC, but in this particular case, I had done it previously. So I'm going to ignore all of the stupid warnings about the vias. Why are my shortcuts not working now? That's better. Now it's working. Okay, so I'm going to save again so that I can then do the production file generation. Jack's Tech says, change the DRC rule. Yeah, I could. Yeah, Sion says, of course, you didn't change the view mode, you filled the copper, so that's a change. Well, is it though? Because if you generate the production files, there will be no difference. It's if you have the polygon on there and then you generate the production files, the polygon will be filled. And that doesn't matter whether you are viewing it with the polygon filled or not. At least it shouldn't. This would be seriously broken if that generated a different outcome when you run production. So at the moment I'm going to do, what am I doing? Manufacturing. All right. Cam preview, cam processor. Let's run cam processor. I've got, this is a 4-layer board, isn't it? I can't even remember. What have I got? Yes, it's a 4-layer board. And it doesn't really need to be. I could have done it as a 2-layer board, but I don't care. I'm going to stick with 4 layers. So I've got a dedicated 3.3 volt, come on, plane and 3 ground planes. So let's see what else I've got here. Dropbox, Gerbers, open folder. All right. So the way I manage this part of my process, and I'm actually curious to know what other people do, the way they handle this. In Dropbox, I have a folder just called Gerbers, and inside that are typically 2 directories. There is archive and to order. So ignore the Gerbers directory for now. And what I do is when I generate production files to send off, I run the cam script, and I create the Gerbers here. So in this particular case, I'm going to compress that. So I'm going to make an archive and call it OpenKO V10. So I've now got an archive of the Gerbers. And whatever I'm going to order, so I'm going to now, okay, I'll slow down a fraction and explain what I'm doing. So the Gerbers are in this file. This is the output that came out of Fusion, ready to send off for production. But for simplicity of uploading, I zip it, and then I put the zipped version into this folder called to order, and I use that as a queue. So if I'm working on a few things and I want to queue up multiple PCBs to put into an order and not forget about them, what I'll do is generate the production files and put them in this to order folder, and I'll keep them there. And that way, if I'm doing something like placing an order and something goes wrong with the order process, I've got those archives sitting there. But now I no longer need this bare directory, so I'm just going to delete that. So I've now got the archive directory and the to order directory. So now what I can do is go to JLC, and I will bring that up in a second. Where are we? Here we go. So let's go to JLC, order now. All right, in just a second, I haven't been reading chat, but in a second I'm going to check chat and see what people are suggesting. So what have I got? OpenKO, gonna add that one, and it's uploading. Okay, so JLC is on holiday for another couple of days anyway. All right, what are people saying? Oh, I just glanced down and I saw Peter Lawler saying, I'm AFK for a while, been at the keys today for 6.5 hours, no break. Hang on. You said you've been at the keys for 6.5 hours today. It is now almost 10:30. Did you get up at dark o'clock this morning and start working? What have you been doing? How have you been on the keys for 6.5 hours? And it's this time of day on a Sunday. Okay, so Stephen says, each project has its own folder and various revisions are stored within. Yep, cool. Scott says, I create the Gerbers in the project folder, which goes on GitHub, then create a tar.gz with the date in the name when I order. Okay, cool. That's a good way to do it. Peter said, yeah, AFK for reals now. Henrik asked, how many PCBs am I going to order? Probably 5, whatever is the minimum. Question is, do I want to just do green? Okay, so what have we got? PCB quantity, 5-pack, industrial, whatever. I never even look at this. Product type. Why do they care? Aerospace? Medical? Does it make any difference? In the aerospace medical industry, strict product requirements are maintained to ensure safety and security of all users. Okay, so presumably if I click this, they'll just charge me more and take more care or something. If I make it blue, is it going to cost me any more? $10.87. Went to $18.18. Yeah, might as well make it blue. It's kind of the theme. What else? What other options do we want? Everything default. Everything PCB assembly, no. Stencil, no. I'm only going to be making a couple of these by hand, so I don't want to pay for a stencil for this. I'll just do the old solder paste in the syringe sort of thing. Okay. I need to drink more of this coffee or he's going to be totally cold. I will be back after another network chuck break. That's better. Okay, so Henrik asked if I can select flex. All right, if I select flex, what happens? Can I do a 4-layer flex board? It would be kind of funny to order this in flex. No, you can only do 2 layers on flex. So that is not going to work. But it would be kind of entertaining to do a version. What have we got? 4 layers. I hope selecting that didn't screw it up. And I hope it didn't do something. Oh, okay, good. It says detected 4-layer board. What I was momentarily worried about was changing it to a 2-layer process may have meant that they dropped intermediate layers, but luckily it didn't. So we still have 4. We got blue, everything default. Calvin says lead free. No, whatever the. No, I'll just go regular hassle with lead. Scott says, if you can't keep your coffee hot, time to switch to beer. I don't like beer. And also the problem is that then you've got the problem of keeping your beer cold. Unless you're a POM, in which case, yeah, you're in trouble anyway. Drinking warm beer. David says, so shouldn't you be doing lead free? Henrik says, look, the lead free price, it's so expensive. David suggested Peltier cooling under the beer. Yeah. Shouldn't I be doing lead free? In my little syringe of solder paste, I've got, hang on, I'm going to change to lead free and see what the price does. $18. Now does it change? It went to $50. What? Seriously? What? I thought that, so that is, I am really surprised by that. I thought that lead free was the same price as leaded at JLC. I didn't realize they were charging more for lead free. Okay. I normally just leave it at the default because the orders that I do through JLC are normally just like little prototypes and things, stuff that I'm hand assembling. So I just leave it on the default. And my syringe of solder paste that I use for putting on by hand is leaded paste. So, well, I'm just going to leave it on hassle with lead. Jack's Tech says they are charging for the guarantee as they now have to test it. Right. Interesting. Yeah. Okay. So by test it, is that a requirement of some kind? Yeah, I don't know. That's baffling. Anyway, whatever the reasoning is, I'm just going to leave it as hassle with lead. Okay, so what are we up for? 18 bucks plus shipping. Shipping is going to be 28. I wonder... so I'm not actually going to place this order right now. I'm going to queue up more PCBs and put them through in the same order, because otherwise I'm paying $28 for shipping on an $18 PCB, and that irks me. Okay, Jacksec says if they apply the PB free logo, they have to be sure. Henrik says also look at the 2 ounce copper price as well. Yeah, I've done 2 ounce on boards in the past. Like which board? I've done it on boards with motor drivers where you need high current and you've got a lot of thermal dissipation. So the Stepduino was produced on a 2 ounce copper process, and it's actually quite surprising. Like, if you've got a bare PCB that has been made with 2 ounce copper, it's noticeably heavy. It really does make quite a difference. So you can specify inner and outer copper weight. Okay, just for shits and giggles, let's go 2 ounce copper on the outer, and it went to $117, still with 0.5 ounce copper on the inner layers. I'm going to go for 2 ounce on the inner. This is going to be freaky. $166. Okay, so that's with 2 ounce copper on both the inner and outer layers. But let's... I know this is a funny thing to do, but let's go for 1 ounce on the outer and 2 ounce on the inner. I bet very, very few people select this particular combination. So if I selected this, so I've got blue color PCB and I've selected default, so 1 ounce outer copper, 2 ounce inner copper, and that's like, yeah, that particular combination. I bet that nobody else will be ordering that specific combination in a 4-layer board within a few days of me placing this order, which means that if I order this and I'm ordering 5 PCBs, they probably have to dedicate an entire panel just to doing my boards. So it's kind of understandable why they would charge a lot. But let's not do that. Let's go for 1/2 ounce copper, just the standard. Keep it all normal, 18 bucks. And if I'd selected green, this would have been 10 bucks. But I want it to be blue. Maybe I should make maybe I should make green the official color for Super House projects, so that I can always go for the cheap PCBs. Scott says 0.25mm traces on 1 ounce copper are good for about 1 amp. Takes a bit to convince me to go heavier. Yeah, kind of, but you get a lot of temperature rise. I've been doing, so I've been using tracks around, so on motor related things, I'm talking about things like the water cannon project. I use tracks on that are often, like I often go to 1.27mm tracks, so that's 0.1 of an inch. And even on a 1.27mm track on an outer layer, so 1 ounce copper, if I stick the thermal camera on it, I can see it getting hot when I'm running a lot of current through it. Like quite many amps I'm talking about, but I'm driving big motors. And I'm always paranoid. I know people go for really small trace sizes, but it's a trade-off. You'll get thermal, you get temperature rise. And things like current ratings on tracks are based on an acceptable temperature rise, and the rise is often really high, like 25 degrees. So yes, you can have a lot of current through a small track, as long as you don't mind the fact that that track is going to get stinking hot. So you need to be able to get that heat out somehow. What am I doing? That's right, I should just hit order, shouldn't I? So where are we at? Just to review, because I've been screwing around with this. The board is uploaded. It's FR4. I don't have flex selected anymore. It's 4 layers. I'm doing 5 of them. I might change that quantity possibly. I only need 3 for myself, so I think 5 is enough because I don't think anybody else is ever going to care about this board. Is red? Oh, okay, yeah. Stephen W says 0.1 is 2.54 millimeters. Yes, you're right. Sorry, I had a brain fart moment. 1.27 millimeters is 0.05 inch. Now, now, oh, I saw a comment about current through vias as well. Hopefully I will remember to get back to that in just a minute because there is an interesting experiment being done. I can't remember who's doing it. I just saw on Twitter a couple of days ago someone talking about, all right, let's chase this squirrel right now. Someone talking about how much current can you really put through a via, and is it a problem to put a via in the middle of a trace? Is that going to reduce the current that can flow past the via? Let's see if I can find where this was. Did I retweet that? No, I did not. So, sorry, I'm just looking at my replies. No, I might have just like clicked like or something on the post and didn't do anything else to save it. Can I see? Oh, likes. Okay. Yeah. Hang on, I'm going to bring this up because there are some interesting things in my likes history. Where are we? Oh yeah, this one, I just saw this morning. Charlie Brew said, I'm really hoping the soldering yield on this USB-C jack is good, otherwise the rework tech is going to hate me. Oh, look at this. Switch 4 right on the back of the USB-C jack. Yeah, the pins on the back of this sort of style of jack can be a real pain because if you don't get the solder quantity just right through the stencil, it's pretty common to end up with bridges on these connectors, which means you've got to get in there with the solder wick or something and rework them. So actually one thing I'd be interested to hear from Xeon, because Xeon does quantities of this stuff, like volumes that I just don't do. So what sort of yield rate, Xeon, do you get out of these, out of USB-C jacks and the pins on the back of them? Do you have to do much rework on these? Because yeah, this would be a pain in the ass. As Charlie says, rework technicians are going to be cursing my name. Yeah, the only way to really do that effectively would be to remove switch 4, or switch 104 rather, and rework the connections on the back of that USB-C connector, and then put switch 4 back on again. Otherwise, you just couldn't get in there to do anything, and you'd probably melt the switch. Oh yeah, this is something that Joe Hiller did recently. Oh yes, this is part of a thread. So I'm going to go back to what this is in reply to. So Arturo said, I'm about to commit PCB crimes, and then invited people to post their pictures of their PCB crimes. So look at this. This isn't, I don't think this is a PCB crime. This is clever. This is cool. Look at this. So we've got through-hole resistors at right angles, so they're perpendicular to each other, and they're crossing. So there's a resistor put down first against the PCB, and then another resistor put across the top of it. And at first glance, if you just see this out of context, you think, what the hell is going on here? Why not use a via or something instead? Why has it been routed in this way? And if you look at the shape of this PCB, it's got this strange shape, and it's got these RGB LEDs that are sticking down from it. And then there's this snaking line of resistors up here, and a snaking line of LEDs here, surface mount LEDs. So this is a Christmas tree PCB. And the alignment of the resistors here is the decoration. You can see that this resistor band is like a garland around the tree. And then these are like stars on the tree, but made out of resistors. That is really cool. That is that is not a PCB crime. That is clever. And this one that Joseph Chu put on. And okay, so you might look at this and think, yeah, that's fine. Like, what's wrong with that? The PCB is an odd shape, but it's probably an odd shape to allow for clearance inside the enclosure. When I first saw this, I thought, oh yeah, there's obviously a battery or something that goes in here, maybe like an 18650 cell that sits inside that cavity, and there'll be like a cable clearance or something up here. So there's probably like a cable that wraps around and goes into this connector. There's some kind of clearance here, I don't know what it is. So at first glance I thought, yeah, there's nothing wrong with this. But the explanation is, so Arturo asked, where's the crime? The explanation is, Joseph said, included the keep out layer in the released fabrication file set. They interpreted the keep out, so no copper to interfere with antennas, as board cutouts. The board is supposed to be a rounded rectangle. Yeah, so the board was fabricated with the keep outs actually cut out of the outline of the board. So that was just a keep out area. It wasn't meant to be a cutout at all. So that was a total screw up in the fabrication process. And this, 2 crimes in one. No, this is cool. I like this. That's a really nice looking thing. What's this one? Somewhat related to the earlier one about keep outs. So there's a layer there with no copper under that. What else? So Joey Hiller posted this. This is making a footprint that allows you to solder a barrel jack directly onto the PCB so that it's a fixed connector. So 12 volt, what does it say? 12 volts out. Okay, so this is a voltage regulator module, so, or a switch or something, like controlling power is my guess. What does it say? Something mapper? Can we zoom? Blackview mapper. So my guess is that this is a power control thing. So power comes in here, power goes out here. But the nice thing is that footprint that, let's see, we'll bring it up here. So this footprint is designed to have part of a barrel jack just put down against the PCB and then soldered in place. And my guess is that these holes on the side, these holes here, are so that what you do is put the barrel jack down against the PCB and then loop a piece of wire over it and solder it on both sides so that you get good mechanical strength and bonding the power jack to the board. And then of course you can connect into the back here for the center connection for a positive. So that's pretty cool. So once again, that is not a PCB crime. What's this one? Micro SD, SOIC 8, okay. So the micro SD, so you could solder maybe a connector would go onto that and then break it out so you could stick it onto something else and put it down on a SOIC 8 footprint. What else is going on here? A ground bridge between different nets in Kicad on inner layers. What else is there? I don't know. Anyway, why did I get onto that? I don't know. I'm going to bring this back down off the screen. I'm just having fun talking to myself at the moment. Where are we? Okay. I have not been reading the chat at all. I'm just amusing myself looking back at stuff. All right, so I've got to find this. Where is it? Where is it? Oh yeah, there's that. Oh yeah, that's right. Xeon has released the Reflow Master Pro 2 firmware, the beta of it. Here we go. Okay. This is the post that I was looking for. So, all right. I know I chased some squirrels, but this is actually kind of on topic for the whole via discussion on the PCB and current rating on tracks. So Matt's posted some stuff asking questions about power and then has generated this test design. But before looking at that test design, let's have a look at, it's not in reply, so I'll find the original. Where was Matt's? Here we go. Okay. This is really interesting. And it made me stop and think about this and the way I do things out of habit. So the question is, how would you do a via off a power trace? Here the trace is 0.6 millimeter. So it's a fairly large trace, like it's a power trace. Doing it like A will reduce the width of the trace quite a bit, but the distance is not long, so maybe it doesn't really matter. So it's only a short thing. B seems a bit silly and looks like a stub, but it isn't. And C maybe. Okay, so we've got three options that are here. Now, this is, I'm going to give some opinions on this in a second, but what you can see here, at first glance, if you look at this layout, what you might think. So you would think that B is good in terms of not interrupting power running along the trace. You're tapping power off the trace to take it to another layer, but you're not interrupting flow through at all. And C, similarly, provides lots of copper on the surface of the board for power to flow through. Now, my thinking on this previously, so up until fairly recently, would be that A is potentially a problem and that it will cause a weak point in the track where you might get a hot spot because you've got less copper available for current to flow through. But recently, and I can't remember where I came across this, I came across someone that was talking about power flowing through vias, and it was the question of how much current can you flow through a via compared to flowing through a track on the surface of the board. And from what I read, the answer is a lot. Even so, you can have filled vias, like plugged vias, which are filled with like solder or something, so that it's like a solid plug through the board. Normally vias are just little tubes, so they've got copper lining the inside of it. It's a hole through with copper around the outside, so it's like a copper cylinder through the board. And I don't know if this is true, so this is why the result of Matt's experiment is going to be very interesting, and I'll get to the experiment in just a second. I'll show you that other test board. But the point I'm getting to is this via, so going from the top edge of the via here, if you wanted current to flow there, say we're flowing from top to bottom, just doesn't matter which direction, but say we have current flowing from the top part of this track here where it's nice and big and unobstructed, and it's flowing down here to this part of the track where it's nice and big and unobstructed, and we've got this via in the middle as a speed bump and potentially a higher resistance or a lower current capacity point. Now, what I read is this via, this area here, probably has a higher current carrying capacity than the track on either side of it. And when I heard that, my initial reaction was, what the hell? That can't be right. Because you've just drilled a big hole right through the middle of the track and you're passing current around the hole using these little traces. And when you look at it in 2 dimensions like this, like in a top-down view, you think, you're definitely introducing a weak spot where the current is restricted to flowing around these little parts of the trace. But this is the interesting thing. If you think about this in 3 dimensions, this top part of the trace here, so hang on, I'm going to zoom in a bit more. All right, I don't know if that even helped. So the top part of the trace here, if this was only 2 dimensions, that would be correct. These would be slightly higher impedance points in the trace, but they're not, because current can flow in 3 dimensions. And it comes, say it's coming down here, gets to the edge of this hole, it doesn't just divert around left and right to go around the hole and stay in the plane. What it can do is flow down through the edge into the via, and remember the via is a copper tube, so what it can do is flow down and around the walls of the via. And the via could be, if you've got if you have a standard PCB which is 1.6 millimeters thick, this copper tube is going to be 1.6 millimeters long. So the plane or the face of the inside of the via effectively is a 1.6 millimeter wide copper path, and you've got 2 of them around the 2 sides of the via. So the current flow around the edge of that via, or its ability to flow current, is actually really, really good. There's probably more copper on the inside of this via than there is on the track on the surface of the PCB. Now, the copper that's on the face of the via is probably thinner than the copper that is on the surface of the PCB. So if we're talking about 1 ounce copper, so a standard copper weight on the PCB surface, the plating on the inside of the via is probably not going to be as thick as that 1 ounce copper. But there is so much more of it. It's the skin around the entire 1.6 millimeter deep via. So, yeah, far from being a weak point, this via, and also when I've designed boards in the past, it's been pretty common for me to drop multiple vias on a track to take. In fact, I wonder if I can find an example of this. I'm pretty sure I could. I'm going to pull up something like some board that I did years ago, a long time ago. Let's see what I can find. Like maybe the 11. That may have it. 11, or the Ether 10 or something like that. Doesn't matter what. 11. Yes. Okay. Here is a good example. I'm going to bring up in Eagle the design for the 11. So this is the Freetronics 11, and all the colors are totally screwed up on these layers. But what you can see here is, if I go to, let's just turn off some layers. Now I've got to remember how to, here we go. Okay, top and bottom. I'm going to turn off bottom layer, just to make this a little bit clearer. So what you can see here is, this is on the 5 volts, the 5 volt rail coming from the regulator, etc. So this is a big decoupling cap. The 5 volt regulator is over here, and so we've got power in. So V in comes in here, comes in from the barrel jack through the reverse protection diode, and then we've got this huge track that goes to the input on the linear regulator, and then the output of the regulator comes to here. Oh, hang on, no, sorry, that's ground. The output of the regulator comes to here. That's it. And then it goes off to other places, as you would expect. But the 5 volt rail, so we've got vias here alongside the alongside the regulator, and there are rows of them. This is actually for thermal stitching. This is so that heat will be transferred through. So having a whole lot of vias there is perfectly legitimate. But, and you can see here it goes down to stuff on the bottom layer. Now, on the bottom layer, if I switch to layer, I'm just going to go into single layer mode. Okay, so this is the bottom layer. And then what you can see is a major track that comes along here, and it goes to this capacitor and goes to the 5 volt thing up there. The point, I'm rambling, the point is, you can see here that I used pairs of vias, and you can see down here on VIN, I used pairs of vias because I was worried about the current capacity through the via. Because in my brain, I'm thinking, I've got this really large track and I want to take a decent amount of current and pass it through to the other side of the board. So if I put multiple vias along that, it's going to increase the current rating or the current capacity for that transit through the board. So it's obviously better having multiple. Why not do a few of them? But that via, just one via, may well have a higher current capacity than this track by virtue of the fact that it is a complete cylinder. So if you unwrap that, what is the formula? It may not be the same. What is the formula for circumference of a circle? If we take what size, and also what size is that via? So we could work this out. It is a 0.5 millimeter via. Somebody tell me is it 2 pi r is the circumference of the circle. So circumference of circle. So many years since I was at school. Yeah, 2 pi r. Okay, my memory was correct. So the radius is going to be 0.5, and the solution. All right, so this, yeah, hang on. I'll just show you what I got because I cheated and asked Google, of course. So if we have a radius, oh no, it's not 0.5, it's 0.25 because it's radius, not diameter. All right, here we go. So a via with a radius of 0.25, which means that we're dealing with a 0.5 millimeter via. If you unwrap that cylinder and you are passing current directly down through the via, it's the equivalent of a track that is 1.57 millimeters wide, which is like crazy. So each one, if you imagine this via being like a vertical track through the board, it's the equivalent of a 1.57 millimeter wide track. Now, what is this track? And this track is 1.4224 millimeters. So each of these vias has more width than this track. Anyway, I've belabored that point enough. It's something that I had never really thought about, and when I saw some reference to this, I was kind of surprised, and I thought, that can't be right. Oh, and you can see I've done the same thing here. Look at this. So I've got this U ground, so that's a USB ground track, and I've doubled up the vias here. These are, once again, are 0.5 millimeter vias, and there are 2 of them, which means that it's 1.5, what was it? Nearly 1.6 millimeters wide for each, so that's 3.2 millimeters of vertical conduction width through the board compared to the track, which is way less than 3.2 millimeters. So those vias are much higher. Now obviously, because they're not exposed on the board, we've got thermal considerations as well. As the temperature on the track rises, the track that's on the surface of the board is going to be able to radiate it out, and its temperature rise will not be as much. A via is constrained by the board, and therefore it will have more problems with temperature rise. But still, I think the point stands. The point being that this solution, A, there's nothing wrong with that. That is not a weak point in the board. Current can flow down here, down into the body of the via, around the wall, like the skin of the via, and back up and continue along the track. And there will be more copper for it to flow through at the point of the via than just on the track itself. So let's just go back to normal view. All right, so the point of all of that is somewhere down here. No, I think it might have, I think Matt's did a different thing. Okay, so Matt's then said, I sent for a test PCB after the discussion about via placement in power traces. It tests the resistance in 0.5 millimeter, 1 millimeter traces with and without vias in 5 configs. I'll also use it to test crosstalk in 5.5mm and 540mm space buses, also test holes for M2 screws. All right, so this is the test that has been sent off. And let's, oh, that's annoying. I'm trying to zoom in and the adaptive design it just keeps resetting it no matter how much I zoom the browser. Can I do it this way? Yes, I can do it that way. All right, so on this test track, you can see there's a tinned version here. That'll be interesting to see as well. And then you can see here with vias that are interspersed along the track, but the track continues on the same side. And here it is alternating top and bottom, passing through vias. So yeah, and I presume that that length, oh no, it's a different thickness. It's hard to tell, but it looks like this part of the track is a different thickness to this part of the track. That could just be a rendering thing, I don't know. But yeah, doing this comparison of a straight uninterrupted track versus one with vias in it, if everything that I've just been saying for the last 15 minutes is correct, having these vias in the track should not decrease its current capacity or increase its resistance. This track should be just as capable, and this one here that alternates top and bottom as well should be just as capable of carrying current as a track that runs all on the same side with no via interruptions, just a single straight piece of copper. And oh yeah, these are the crosstalk test parts of the thing. So I am going to be very interested to see what happens when Mats gets that board back and we can see what the result was. Yeah. Now, what is everybody shouting at me? Let me try to catch up on the chat just for a moment. Yeah, Stephen says thickness will be different though. Yes, that's true. Right. Dentistry says I may be overcautious, but I definitely over via. Yep. Yes, I do that too. Hang on. Didn't happen on Bathurst weekend. What was this? It's just a Bathurst? That's not on this weekend, is it? Surely not. Okay, so sorry. I've gone into random reading the chat mode. So Trady says, I'd be interested to see what happens under a thermal camera with some decent current flow. Yeah. I've been doing a bit of thermal profiling of boards recently because of heat issues on some boards, and I've been kind of surprised by how hot things get that you don't think would get hot, like reverse protection diodes on boards. It's kind of surprising. You can have a board that is not pulling a large amount of power, like not pulling a lot of power, might be a couple hundred milliamps or something. So my standard go-to polarity protection diode that I put on lots of different boards is an SS56 Schottky diode. Just because being Schottky, it's got less of a voltage drop than a regular silicon diode, and it comes in a nice convenient SMA package, same as like a 1N4004, you know, the standard sort of power diode. So I've got a reel of SS56s in the machine, and I put them down just wherever I want to do polarity protection. Like in that place that I just showed you on the 11, where it had the reverse protection diode in the V-in rail. And I was looking at a board with the thermal camera about a week ago, and I was looking for something else. Like, I was not paying attention to the input side of the board because there was some other part that I was worried about getting hot. And when I put it under the camera, I could see that the input diode was becoming noticeably warm. Well, it was a few degrees more than everything else on the board. So on the thermal camera with its auto adjustment for like range, what do you call it? Like an auto exposure, I suppose you'd call it. It was showing a hot spot on the diode coming into the board, which was, I think, maybe 3 or 4 degrees hotter than anything else on the board. The rest of the board was within a degree or so. And it just kind of surprised me because I hadn't thought of the reverse polarity protection diode being the weak spot, but there it is. That's why. All right. Yeah. So Jack's Tech. Oh yes. Okay. Just scrolling back. A couple of interesting things here. Henrik said, not the width but the length, which is defined by the board thickness. Yes, that's right. So the width of, if you're talking about a via going through a board and imagining it like it's a cylinder, imagine cutting the cylinder and unwrapping it, so you're turning it into a straight flat path, then the length of that path is defined by the thickness of the board. The width of that path is defined by the diameter of the drill that is going through the board. Somewhere was it? This is a good point. Some Call It Fun said, I guess multiple vias might protect against a manufacturing defect. Oh, I just realized I've got top chat turned on, not live chat. I've got to switch to live chat. There we go. Might protect against a manufacturing defect, even if not needed for current rating. Yes, that's true. So one thing I don't know is the consistency of the plating on through holes. These days with current PCB manufacturing techniques, it should be very good. The quality that that is obtained through cheap, like prototype level PCB places like JLC PCB is incredible. They do a very good job. So I suspect that the quality of their plating is quite consistent and quite good, but we don't know how thick it is. Maybe there are specs on that, and there was another comment related to that. That's right, Graham Brown asked, any idea what the via plating thickness is? I do not know, but PCB via plating thickness, let's see. Okay, oh, there is a spec for this. I'm just going to bring this up. Ooh, bring this up here. Where are we? Okay, PCB via structure. Where have we ended up? ePiccolo. I don't know. I haven't come across this site before. I just did a quick search. All right, so this is a standard PCB via structure. So it's a hole through, it gets plated, and we've got traces on different layers connected to annular rings which are connected to the hole that goes through. The barrel, the pads, yep, okay. With unused pads retained, yeah, okay. Annular ring, 90-degree breakout. Interesting. All right. So offset and yeah, PCB via size. Yeah, I'm kind of just scanning through this, seeing if there is anything else that's interesting or relevant to this. So clearances and tolerances, drill to copper clearance. Yeah. So what I'm interested in is the plating, and here we go. According to IPC 6012, classes 1 and 2 require an average copper plating thickness of 20 micrometers or more. Micrometers? Or micrometers? I don't know how you pronounce it. I'm going to say micrometers. And no less than 18 micrometers in thin areas. I know I've been told off for this before, because that, people call that sort of thing a micrometer, I think. While Class 3 requires a 25 micrometer average thickness or more, and not less than 20 micrometers in thin areas. Same holds for buried vias as well, but not for micro vias that don't have a barrel and have relaxed requirements regarding plating. Alright, so question is, 1 ounce copper, what is the thickness of 1 ounce copper? 1 ounce PCB copper thickness. It is 35 micrometers. Okay, so the copper on the surface of the board will be 35 micrometers thick, and so according to this, now I don't know what standard JLC or anyone else does this to, but it says classes 1 and 2 require an average thickness of 20 micrometers, which is just a bit more than half of the thickness of the surface copper on the board. Alright, so that's interesting. So if we derate, alright, so that is 20 compared to 35, so it's a bit more than half. But then if we derate a little for the fact that it is inside the board, so there'll be less thermal dissipation, imagine it's half. So the copper on the via going through the board is going to be the equivalent of half of the copper that is on a top layer, which means that if we have a via going through the board, now say you have let's do this thing, let's work this out. Did I still have, no, I think I closed the tab for the diameter of a circle. Let's figure this out. We're going to, so imagine we have let's find, all right, I'm going to switch back to Fusion. All right, get out of this. Discard. No, I don't want to save it because I didn't actually change anything, you stupid Fusion. All right, so imagine that we have a power track. Let's use VIN. This is going to be kind of interesting. What's going through my head here is doing a calculation. If I've got a power track, how big does the via need to be to have equivalent current capacity to transit the power to another layer on the board? So in this case, we have this VIN track, and that is 0.8128 millimeters in width. Now, it's not taking a whole lot of power, but the way I'm going to work this out is we've got a 0.812 millimeter track. Now, if we are going to half the copper thickness, say equivalent to half, we need it to be double that. So we need it to be 1.6 millimeters. So we want the via circumference to be 1.6 millimeters. Let's do this, 1.6 millimeters. And what's it going to give us? So the diameter is then going to be 0.51 millimeters. All right, so if we have a via of 0.51 millimeters, that has the equivalent cross-sectional copper to a track that is 0.8 millimeters. That is interesting to know. Because the funny thing is, just by default, I stick 0.5 millimeter vias everywhere. All right. Now, unless someone can see something that is totally screwed up with my logic, so what we have here is a 0.8 millimeter wide track on this power in. The current flowing on that track, like the current carrying capacity on that track, will be the equivalent of a 0.5 millimeter via that is plated to 20 micrometers thickness. So, that is interesting. I've either learned something today, or I am now totally misguided because I have screwed up in some way. Okay, where are we? Jackstack says, yes, it's counterintuitive, but it would depend on where the current actually flows. See the current outside the wire from Veritasium. Yeah, I haven't seen Veritasium's video on that, but there are many other very good videos around about where is the energy in an electromagnetic field, and it is not necessarily in the copper. It's in the field that is around the copper. So yes, it will depend on where it flows. Stephen says, I still have one of your 11s running something. It's got to have been running non-stop for about 8 to 10 years now. That's awesome. It's good to hear that, Stephen. Jackstack says, probably more capable as there's more air exposed to the track. Yes. James says, order that board and test it. Where are we? Hang on. Okay. I am way behind on chat. Morning. Oh, so someone turned. Oh, Gerald? Johnny? Oh, Johnny arrived. Johnny Bergdahl. Welcome. Yeah. Okay. Dodgy said Bathurst is next weekend. Right. Okay. I thought I would have heard something about it if it was this weekend. So Johnny said, have I seen this 20 ounce PCB? What? Okay, I have to click this link. There is no way that I'm not clicking this link. I think I did see this at some point. Oh, this is brilliant. Yes. Yeah, this is a while ago, isn't it? Oh yeah, posted 7 years ago. Yes, I've seen this. I just received my 20 ounce PCB. Soldering is going to be fun. Look at this. This is beautiful. 20 ounce copper, and if you were going to do something like this, you would just about CNC machine these traces and glue them to a piece of board. Oh, that's crazy. And you can see some little surface mount parts sitting here. So if I zoom in on this, look at that. Those look like what, 0603 parts maybe, just judging by what it feels like and the printing that's on it. It's probably 0603, but look, it's lower than the copper trace on the board. Yeah, look at these the pads. They're sitting up. So everything that gets mounted on this is going to be sitting up above the fiberglass because it's being held up by this crazy amount of copper. How did they do that? And the other thing is that because this copper is so thick, it'll be etched. Yeah, they would have had trouble etching it because of because what happens is that as it etches down the copper, you don't get perfectly vertical edges because it'll tend to well, you get two factors. Firstly, the etchant is in contact with the top parts for longer, so it tends to sort of etch in a little bit. So you end up with the side of the track being shaped a little bit like this. So it'll be sloping out because you start with a solid piece of copper and then you're etching into it chemically, like etching down. And as the etch goes down, the etchant is still in contact with the top part when the bottom part hasn't been exposed yet or hasn't been etched away. So you end up with things that look like you've got sloping sides on all of the tracks. And that means that if your tracks are thin, it can over etch at the top because you have to etch it for longer to get all the way down. If you imagine, the etchant has to go through, so this is 20 ounce copper, which means that it's 20 times thicker than the copper on a standard PCB. So it's got to be exposed to the etchant for 20 times as long. So the top edges are going to be over etched. That is, just producing this is quite a production challenge. That's very impressive. Right. Now, where are we? 20 ounce. Oh, Johnny said, so no text-to-speech today. I've got to admit, I totally forgot about that. It's already 11:24. What the hell? How is it 11:24? I'm going to pull up Superhouse. Where is it? Superhouse dot. Is it Mitchell? I can't remember. Mitchell. There we go. No, it looks like Mitchell is not running the text-to-speech anyway. So no text-to-speech today. Right. Is that... okay, so Dodgy asked a very good question. You're right. I was falling into the trap of using just shorthand terminology. So Dodgy asked, when you talk ounces, is that X ounces per given area? Yes, it is. And I can't remember what the... Because, let's see, PCB, copper, thickness, 1 ounce. It is finished weight. How is it? What area is it done over? Yeah, it would make a whole lot more sense to specify the thickness, just in my brain anyway. But for some reason, this is how it is defined. So 1 ounce copper, which is 35 microns thick, standard internal layer copper thickness for standard construction, blah, blah, blah. But where is the area? It's ounces per square foot. That's it. Yep. Which is a ridiculous way to be measuring the thickness of something. Okay, we want to measure the thickness of a flat sheet of something. So let's measure the thickness in its weight per square foot. Like, what? Who came up with that as a standard way of measuring something? That is just totally obtuse. Oh, anyway. Okay. That's a set of verniers. Yeah, okay, or calipers. Where was the stuff? Where was I up to? Oh, interesting. So Mad Techie says, a PCB manufacturer I used to use would supply a cross-section encased in resin and a full report of plating thicknesses. Wow, that is some top-level service. That's quality control taken to the extreme. Really, really cool. Yeah. Ah, cool. So, Mad Techie, please do that. So, following on from that comment, Mad Techie said, batches were pretty large. I'll post a pic on Discord next week if I remember. Yeah, I would love to see a picture of one of those cross sections with the measurements of the thicknesses of all the layers and things. Yeah, Johnny wants to see it too. Henrik asked, how good am I with math and resistor dividers? I don't know. I cheat. The thing is that there are online calculators for everything these days. Resistor divider calculator. This is what you should do, Henrik. Go to voltage divider calculator and put in the numbers you want. So we've got a source voltage up the top. Say we want to measure, we've got a 12 volt rail and we want to measure an output that is going to be in the 0 to 3.3 volt range so that we can measure the voltage on an ADC on a microcontroller. So let's say we want the output to be 2 volts and we want just make up a number. Say the bottom resistor is going to be 10,000 ohms. Calculate, that means the top resistor has to be 50,000 ohms. So we've got a 50k and a 10k resistor. And now you've got a voltage divider that will give you 2 volts out of 12. So I don't do any of that stuff in my head. I'm not a sucker. There are calculators for all of these things. Where are we? Johnny says I'm 20 minutes back on chat. I sure am. Oh, interesting. Delane says, when I've found a burned track, the via is okay. Yeah. So the via was not the weak point. If you have a track that changes layers through a via and you run current through it until something goes and burns, it will probably not be the via that burns. It'll be somewhere on the track. Where are we? Oh, Amanda asked, am I doing a 3-hour stream today? No, which means that, sorry, I'm probably not going to get to the presence sensor, but at the very least what we should do is do a quick look at that so that people know about it who might have missed it, and the updates in your document. How is it? Stephen said cats per square watermelon. Imi said it's 1,000th the width of a washing machine. Yep. Oh, okay. So Henrik said, yeah, but if it's more complex, I can't use that. All right. So Henrik, if you've got a question about a voltage divider, maybe the thing to do is post it in Discord with an explanation if it's more complicated than like a simple voltage divider type thing. Because it sounds like it's going to need more explanation before someone can help figure out the solution to your problem. Now, where are we? I think I'm almost caught up on chat, which is amazing. Oh, Jacksec says, yeah, where oxygen meets copper is the burny place. That's true. You need oxygen for burning. Okay, so James said, ounces per square foot is a direct measurement of the raw material, which is copper, since any unused copper could be washed away. Copper is bought and sold by the ounce, so it does actually make sense. Okay, it makes sense from a costing point of view in the raw material, but it doesn't make sense from a design point of view in doing things like calculating current ratings on tracks, in which you need the cross-sectional area of the track. So you need to know the thickness, not the weight per square foot of area of the unetched stuff. But yeah, you're right. In terms of being if you're a PCB manufacturer and you are wanting to calculate how much it's going to cost you to make a piece of PCB, what you care about is how much copper you are putting down on the bare PCB before some of it gets etched away, because that is your material cost. So from a manufacturer's costing point of view, it is the perfect unit of measure. It is telling you how much material you're using. But for anyone else, we don't care. What we want to know is the thickness. So, therefore the cross-sectional area of traces. Right. Now, where was this? Okay, before too much more time gets on, I want to have a look at changes that Amanda has made in the document for the project we were looking at last week, which was the presence sensor. So let me have a quick look in my documents. Project room detector, here we go. And it says edited today. Let's do a quick look at what Amanda has been doing on this. So for those of you who weren't here last week, the very brief recap is that Amanda is wanting to look at a project to make a presence sensor that also does other things. So I'm not going to do the whole recap. I'm just going to look at what might be different. So Amanda, if I miss something that is going to that I missed something that has changed, please point it out to me. Where are we? So presence detector, blah, that's what we talked about last time. Events and statuses passed to MQTT. Oh, interesting. Okay, so this is something that Amanda has added since last week. And there is now a Discord. Hang on, I'm going to pull this off screen because I'm going to launch Discord and I have no idea when I launch it what chat it's going to be in. Possibly in a private chat or something. So I'm going to launch it when you can't see the screen and make sure, oh no, I don't want all of the notifications. I want, where are we? It's here somewhere. Here somewhere. Okay. Which button? That button. Okay, so Discord. Oh, that's, yeah, okay, so there's what's going on here? Oh, okay, is that old? When was this? Later. Oh, okay. Sorry. I am confused. I will get my brain back in gear. So what I was looking for was, where's the project? Presence sensor, here we go. Presence sensor, I haven't looked at this for a little bit. So Amanda said I've updated the linked document for the project. So if you're interested in this, join the Superhouse Discord and then go into the presence sensor channel under projects. And there is a link to this document, the one that we are looking at right now. All right, so things that the sensor should detect. Movement, number of humans detected in the room. That's an interesting one because most occupancy, okay, so there is occupancy detection. That is a term that you will often hear when you're playing with this sort of thing. It's not just motion detection, it's occupancy detection. So is the room occupied? But knowing the number of people in the room is something that most systems can't do. If you have a basic, say like a passive infrared motion detector, it will trigger on motion, but it's got no way of distinguishing that there is one person over here and one person over there. And excuse me. And the fact that there might be 3 people in the room or something. It's, yeah, simple PIR technology just cannot do this. So this takes other methods like millimeter wave radar or vision processing or something. Number of pets detected in the room, fall detection, that's an interesting one as well. Sleeping, doing the distinction between fall detection and sleeping, that is a hard problem. If someone is lying down and barely breathing, is it because they've fallen or is it because they have gone to sleep? Not breathing, that is something that can be detected with millimeter wave radar. Temperature and humidity, so that's general environmental. All of this is general environmental. Temperature, humidity, light level, air pressure, air quality. Air quality is another interesting one. So this would require, my inclination would be to not include air quality in this sensor, because doing air quality detection typically requires a laser scattering particulate matter sensor, and they are A, expensive, and B, large. It could be incorporated into something, but it's probably going to make the form factor bigger than you would want for a little sensor that you put in every room. So that is if you're talking about air quality as being things like particles in the air, like smoke and dust and those sorts of things, which a laser scattering sensor can detect. Air quality can mean lots of different things. Link to a camera stream, yep, cool. And PIR triggered if included, yep. All right, so must have temperature sensor, humidity sensor, light sensor, air pressure sensor, air quality sensor. Oh, interesting. Okay, so Amanda has put an ENS 160 in here. I don't think I've heard of that one before. Multi-gas sensor. Oh, that's tiny. Okay, yes, this is for measuring, it's for detecting volatile organic compounds and gases and things. So this is a gas detector. That, I think, would be worth including. Yes. So this won't detect particles in the air, but it will detect different gases. So what does it detect? True VOC, air quality detection, and supports intelligent algorithms that calculate CO2 equivalents, TVOC, air quality indices, so AQI, air quality index, and perform humidity and temperature compensation. Now the thing is that a lot of these sorts of sensors, in order to be able to calibrate themselves, like if you are reading something like a gas level, then you also need to know the temperature and the humidity, because those things then screw up the calibration for your sensing, for whatever the thing is, your primary sensing objective. And so the nice thing is that if you put sensors like this gas sensor into a project, you automatically get humidity and temperature readings just for free. It comes along with it, because the device has to measure those things anyway. And so typically what they'll do is they'll expose those values in the interface. So you can query them and you'll get the values for levels of volatile organic compounds, and you'll also get humidity and temperature. So that's cool. Nice one. ENS 160, I don't think I've ever come across that sensor before. So let's go to Octopart and see what the deal is with an ENS 160. Whoa. Okay, 50 bucks, 20 bucks, 14. Oh, it's from DF Robot. Oh, these are complete boards, I think. Okay, so this is the LGA. So $6. That's not crazy. That's actually not bad at all. Listed on DigiKey for $10 something. All right, that puts it into the realms of, yes, this is doable. A lot of gas sensors are really, really expensive. So one up quantity, Australian dollars, $16.61 at DigiKey. Quantity of 100, which is usually the benchmark. What I generally find is that when you're looking at price breaks, often you'll get the price decreasing a bit, as you go up in quantity, typically until like 100, and then beyond 100, the rate of decrease of the price is much less. So by the time you get to a price break at 100, which in this case is $10.64, it won't get a whole lot cheaper than that. Like if you ordered 1,000 of them, it might be slightly cheaper, but not massively cheaper. You can see here the jump from 1 to 100, the price drops from $16 to $10. But if you went from 100 to 1,000, it wouldn't drop nearly as much proportionally. So yeah, I would think about this as being a $10 part, basically. Even though in single quantities it's going to cost you 16, or in 10 it's going to cost you 13 bucks. Okay, so all right, that is certainly a good option. One of the interesting things to do would be to look up what the driver situation is with this. If this is all going to be an ESP32, in fact, let's do that. Let's do ESP32 ENS160 driver, GitHub. Here we go. Yes, there are drivers. 4-channel MOX gas sensor with I2C interface. Oh, it's just I2C, so that is pretty easy. Requires a supply voltage of 1.7 to 1.98 volts and an IO voltage of 1.71 to 3.6 volts. Okay, so what we would need is a voltage regulator that provides the power to the sensor, but luckily its I/O can run it up to 3.6 volts, which means it'll be happy with the 3.3 volt I/O on an ESP32. Very good. All right, I like it. That looks like a very good option for an air quality sensor, and it gives us humidity and temperature as a bonus, I guess. Like, I didn't look at the driver. Let's look at examples in this. Doesn't matter what it is. ENS160 dev shield. I could just look up the API, but let's do it this way instead. What are we reading in this example? Print, or setup, measure. So we've got new 2 VOC, so it's got a volatile organic compound value coming out of it. ECO2, do we have a temperature value coming out of it? Yes, we do. Okay, so down here we've got temperature in Celsius and humidity in percent. Very good. So that is already exposed. Okay, so human present sensors, detected humans and pets separately, and fall and sleep and breathing. All right, this sentence / paragraph encompasses a lot. This could be, this should be teased out, because doing things like detecting humans and pets separately, that is a challenge. Fall and sleep detection and breathing detection, all of these things, each one of these is essentially a separate challenge or a separate subtask. So we've got camera for streaming, something like a Realtek AMB 82 Mini. Ooh, good. Amanda is editing this live as we watch. So there's the BGT60TR13C extensive radar sensor, so 60 gigahertz. Yeah, a lot of these little millimeter wave radar modules, I think, run around 24 gigahertz. So this one's running at 60 gigahertz, which is interesting. Is 60 gigahertz the new 24 gigahertz? Now this camera, Realtek, blah blah de blah. What is this camera? What is it? Oh, interesting. Okay, so this is a Wi-Fi Bluetooth. What is on this? Oh, it's got a Realtek SoC and camera for 25 US buckaroos. Oh, okay, so it is the camera and the SoC are all integrated. That's pretty cool. Okay. That is very interesting indeed. Cool. Looks like Amanda is finding all the good stuff for this project. Okay, so Bluetooth proxy for the device in the room section, such as the phone or watch or AirTag. Yep, okay. Wi-Fi, Ethernet with PoE, USB-C. So these are comms and power options here. 12 volt DC power option. Okay, so we've got a few ways of powering it. Nice to have AI face detector. Other options, PIR, battery backup. Diagram to be added here, and then there is a list of things. Ah, cool. Yeah, there's more stuff here that's been added. YouTube links. Lots of interesting things in here. A lot of resources. So this document is up to 6 pages now. So if anybody is interested in this this present sensor project, then please jump into Discord and go into the present sensor channel and have your say. So there is the link to Amanda's document, which has got all the notes so far, and it's got a reference to the last live stream where we were talking about it. Yeah. So this is going in terms of research, like finding all of these things that could go into it. I know I'm misusing the word research, but anyway, and this is coming along really well. Amanda, I think you've got some really good options here. I like what you've chosen so far for things like the air quality sensor, the radar. I haven't looked this one up, but that looks interesting. The Realtek IoT camera thingy, that looks interesting, and pricing not ridiculous. Now this is something that is probably going to it's probably going to end up being an expensive device. I don't really see any way around this. With all of these sorts of features, we're not talking about a $20 or $30 device here. This could potentially be a multi-$100 device. Because if you're talking about, say, in single quantities, $16 for the air quality sensor and $25 for the camera, and what else do we have? The millimeter wave radar. I'm just going to make up a number, say $10 for that stuff. I'm probably going to have people saying, no, but it's only $4 for the radar. Yeah, but by the time realistically it ends up being more than that. So PIR, a few dollars on that. And then there's going to need to be some machine learning stuff to deal with the camera stream and give all of this, like number of humans detected, number of pets detected, fall detection, sleeping, etc. So all of those things will need to be done, I think, using machine learning. So just based on bill of materials alone, I think it would not, you would very rapidly be heading towards $100 worth of stuff. You also need to factor in the Ethernet. So there is the Ethernet controller, which is, how much are those, like the Wisnet W5500s? I think they're like $5 or $6 for the chip. Then you've got the Ethernet connector, which is a few bucks with the magnetics. There's the power supply, so the switch mode regulator and an inductor, there's a few dollars there. Yeah, this will hit pretty close to $100 for bill of materials, I expect. And then there is everything else that goes along with it. So this is not going to be a cheap device, but the capabilities on this, I think, outstrip pretty much anything else I've seen. Right. Where are we? Okay, so Amanda says, oh yeah, so that 60 gigahertz radar is $19 US. And, all right, what have I been missing in the chat? Where am I? Scrolling back. Oh, Johnny. Johnny Bergdahl said, celebrated my birthday, was Wednesday tonight. So really good. Well, happy birthday, Johnny. I hope you had a good time. What have I missed in the chat? Oh, okay, so Johnny says, the FP2 seems really good. Have not heard anything bad about it. The FP2, which is that? Is that the presence sensor? I don't know. DIY. Oh, welcome DIY. Oh, there was no notification? That's annoying. Sorry, I am fading out temporarily because I am just scanning back down the chat. DIY says Mouser has it for $10 a piece. I think that might be talking about the air quality sensor. So that's cool. Yeah, I just clicked on DigiKey as the first thing. Where are we? In S2160 Mouser. Yeah, you're right. So Mouser lists them for $10 a piece, but they're is that in quantity 1? Yeah, this is misleading. See, look at this. Oh no, this is US dollars. So the price is the same, essentially. The prices that I was just telling you were Australian dollars. So if we look at it on Mouser, it said $10.62, I think, in Octopart. But now, once I get to Mouser, look at this, $17.20. So that is, because I'm signed in, and well, I've got my location set to Australia, it's giving me prices in Australian dollars. So this price here, $17 Australian, because the Australian dollar sucks at the moment. It is so bad. In fact, I wonder, AUD, USD, what is it? 64 cents. Ah, that's terrible. Which means if I've got any credit in US dollars, I should transfer it into Australian dollars right now. Take advantage of this. Yeah, take advantage of this poor exchange rate. I think I might have some funds sitting in US dollars somewhere in, I don't know, not in Patreon, that's all transferred over. Yeah, anyway, so Mouser is actually slightly more expensive than DigiKey for that sensor. DigiKey in single quantities, $16.61. Mouser single quantities, $17.20. Back to the chat. Right, might be cheaper in LCSC, possibly. Doji says, why do we want to measure gas? My wife usually does that job for me. Yeah, she will complain. Oh, what's that smell? Cable Tie says, happy birthday, Johnny. You must be at least 21 now. Yeah, at least. Tradie asked, have you seen the specs on the ESP32P4? It's got an AI component. That is... Sorry, I just saw another comment. David mentioned a particulate matter sensor, the SDS011. I am just going to stick this here for future reference. Oh, is this available? Oh, let's learn STEM, so that's no good. Amazon prices are always ridiculous. ESP Home supports it. Oh, what's this one? All right, I'm just going to have a look on this. What about that AliExpress? Let's see if it's listed there. Yeah. What have we got? 28 bucks, 35 bucks. I'm going to look at this one. I don't trust this first one because it's only got one sold. This one's got 24 sold, even though the price is higher. So one piece of the SDS-011 laser particulate matter sensor for 35 Australian dollars with free shipping. Yeah, that does a whole lot. Where are we? Back to the chat. My brain is seriously fading. It's lucky that we're nearly at time. Oh, Johnny says, I did order Seed Studio's new gas sensor. It is 4 chips on the PCB. Yeah, maybe they're combining a few different sensors all on the one board. Because sometimes there are things like a gas sensor that can detect carbon monoxide can't necessarily detect carbon dioxide. Or what else is there? No, those two, I don't know if those are the same or not in terms of the sensor side, but quite often you'll get a gas sensor which can detect one particular type of gas and not another. So if you want to detect carbon monoxide, which might be produced by something like a gas heating system and can potentially be very dangerous, then that might be one sensor. And then if you want to detect carbon dioxide, which is generally, I think, a result of not enough ventilation and just human breath. So if you have an enclosed space with people inside it and lots of breathing, you end up with carbon dioxide buildup in that enclosed space. So you want to be able, and that can then lead to decreased blood oxygenation and headaches and those sorts of things, like trouble sleeping. So if you trouble concentrating. So if you want to detect both carbon monoxide and carbon dioxide and possibly other things like volatile organic compounds, you may need multiple sensors on the board because they use different processes to detect the different gases. David asked, can you use a simple voltage divider for logic level changing from 5 volts to 3.3 volts? Yes, you can. That is a very common and standard way of doing it. So not a problem. I do that very frequently. You can only do that in changing from 5 volts to 3.3 volts. You can't use a voltage divider to go from 3.3 volts up to 5 volts. Because the divider will only ever reduce the voltage, not increase it. But if you've got a device which is providing you a logic level output at 5 volts, so you've got a sensor or something that is running on 5 volts and it's giving an output that is 0 to 5 volts, put a voltage divider on that and you can get that as a 3.3 volt signal, and then you can feed it into a microcontroller or whatever else it is you want to do with it. So yes, a voltage divider is generally the correct solution in that situation because it is so simple and so cheap. It's 2 resistors, costs you half of bugger all, or should I say 2 bugger alls, because the resistors don't cost very much, like $4 for a reel of 5,000 resistors. Resistors are cheap. Where is it? Oh, and also Kim S said, I've been using the SDS-011 for a few years, no problems. Kim, welcome. I don't think I said hello to Kim earlier. Where are we? Oh, Peter is telling me to go home. I think what I need to do is just lie down. That's the main thing. So everybody's telling me it's lunchtime. I am still in this jet-lagged time warp thing going on because of the daylight savings time. Yeah, Peter says, I think Johnny still scrolled way back up there. Yeah, I'm nearly caught up. Where are we? Cable Tie says it only feels like 11 a.m. though. Yes. My curtains have faded, says Peter. Oh, first day of daylight saving and your curtains are fading already. That's rough. It really sucks that you have to replace your curtains every year because of daylight saving. Okay, so David said, the context of the voltage divider query, looking at example of a water flow meter where they're using a logic level divider with a reference voltage in of 3.3 volts. I've used voltage dividers before, but seeing this example I was worried I've been doing it wrong. Okay, so water flow sensors are typically, most commonly, the ones that I've used anyway, have been a Hall effect sensor with a little impeller. And I guess the one you've got is probably the same. So what they do is they have a tube with a little propeller inside it, and the propeller spins, so and it's supported by a structure within the tube, so that as the water flows past it, it turns, and then there is a Hall sensor on the outside of the pipe or inside the wall of it, which picks up the changing magnetic field of the little impeller fan thing spinning. And that way you can end up with a pipe which is totally sealed. There is no way for the liquid to escape from it, and your sensing is isolated from the liquid that you're sensing. And typically those sensors, if they use something like a Hall effect sensor, will give a pulsed output, and it might be, like I'm just making up calibration values, but it might be, say, 10 pulses per litre. There'll be some rating on the flow sensor that says how many pulses you get out of your little sensor, so how many rotations of the propeller per volume of liquid flowing through the pipe. And that is the perfect application for a voltage divider type deal, because you might have a Hall sensor on your flow meter that runs at 5 volts. And typically they have something like an open collector output. So they, well actually if it's open collector, you don't even care. What you can do is put a pull-up resistor on the input from the microcontroller, and when the Hall effect output activates, it goes low and it pulls the signal low and you detect the pulse. And then when the output releases, so it goes high impedance, the voltage is then pulled up by the pull-up resistor to your 3.3 volt rail, and then you can detect the transition between the high and the low on the signal. So on a sensor, like a pulse type sensor that has an open collector output, you usually don't need a voltage divider. All you need is a pull-up resistor to the I/O voltage of your microcontroller. But if the output is being driven both active high and active low, so it goes between 0 volts and 5 volts, for example, then you would send it through a voltage divider to give you the 3.3 volts output. So when the sensor is high, you're seeing 3.3 volts instead of 5 volts. Anyway, lots of hand waving, not a very good explanation. That is just the way it is. But David, if I could see a little bit more, like the actual schematic of what it is that you're working on, maybe I could give more assistance. I don't know. I'm kind of just working from general knowledge here, not seeing what it is that you are doing. Okay, Scott says, had lunch about 9 hours ago. Amanda, thank you very much for the super chat. And it's a pity that the text-to-speech isn't running because there's no super chat thing. So Amanda just donated $5. Thank you. Okay. Oh, nice. David just replied, instant update seems to work with a voltage divider. Haha, cool. So David is working on this live as the stream is happening. Yeah, so, and as Johnny said, yeah, a resistor divider is just fine if you don't have something pulling power. Right. So in Amanda's comment in the super chat, she said there is already AI code for the Realtek AMB 82 mini IoT camera. Okay, so that is where are we? Realtek. This one. So there is already machine learning code. I'm going to sneeze in a second. Oh, just got to the button in time. I don't know where that sneeze came from. Right, okay, so there is already machine learning code for this. The AMB 82 Mini. This is a, yeah, okay, I think this is worth investigating. Hardware cryptographic engine, secure boot, trust zone. It's got Wi-Fi. Yeah, this does a lot of stuff. Hardware overview. Alright. Learn and documents. User manual, schematic. It's got some anonymous 5-star reviews. Alright. Okay. Oh, cool. So David said, no huge assistance needed, just general query as I play around with stuff. Yeah, cool. Yeah, it was a good question. It was an interesting question. Your nose? What have I done to my nose? What's with my nose? I don't know. Dodgy, what are you saying? Oh yeah, Johnny says, I need to license BitLooney's super chat voice, just like Sion did. Yeah, so that when there is a super chat, I get BitLooney going, super chat! Yeah. I should ask BitLooney if that's okay if I use his voice. Ah, I see. Oh, she said the sneeze came from my nose. Yeah, cable tie. So it's funny how everyone now says super chat like BitLooney does. BitLooney started the thing and everybody else is following. Okay, I am going to wrap this up. And I know that we didn't really do anything on Amanda's project here today, other than a quick review of the documentation. But in the preceding week, it looks like Amanda has done some very good research and found some good options here. So the building blocks that need to go into this are largely here. So I think that a lot of this could now be put together by doing something like buying, not necessarily, the way I would do this now is I would buy breakout boards for everything. Now the air quality sensor, I probably would not get the temperature and humidity sensor because it's going to be unnecessary, because the value is going to come from the air quality sensor as well. So you'll end up with 2 temperature and humidity sensors. It's possible that the value that comes out of the air quality sensor will be biased a bit, because often gas sensors have self-heating properties. So maybe it'll turn out that it is necessary to have a separate temperature and humidity sensor. But if we're lucky, we can just use the values coming out of the air quality sensor. So what I would do is I would get a breakout for the air quality sensor. I would get this camera module, just order that exactly as it is. I would order a one of these radar units, but as a module, not just as the bare chip. So a module that you can wire up. And what else is there? Whatever else. And of course there are basic things like the passive infrared motion detector. Then there's Ethernet that would need to be added to it, but that could be done as a secondary stage. So just by getting some of these modules and wiring them together, you could then mock up in a very rough form the basic functionality and start doing some basic software development and try to make something that works before going to the point of trying to smush all of this onto a custom PCB. That is a subsequent step, not a first step. Okay, Peter said, you still here? Yeah, okay, I am going to go. I promise I'm going to go soon. So, as Dodgy says, later peeps, have yourself a wonderful day, or if you're in the southern states, a nice lunch. or as Johnny says, or if you're in Europe, sleep tight. So, thanks everybody for coming along for, I don't know what this is, another episode of something. Another episode of John rambles about random topics and gets distracted by squirrels, but that's what's interesting to me anyway. So, thank you. Oh, one final thing. Next weekend is barbecue weekend again. It's come back around already just because of the offsets of the weeks. It's now the 1st of October according to my computer, which means that next Sunday is going to be the 8th of October. Second Sunday of the month is barbecue day. So if you are in Melbourne and you want to come along to the Super Lab and eat some sausages and chat to nerds like me, come along next Sunday. Get the details in Discord. I will post stuff in Discord in the Super Lab barbecue channel. So, I will, yes, as Dodgy says, another episode of something. Sums it up nicely. So I'm going to go. And you should too. Can't stay here. Okay. Bye.